We have never seen them directly, yet we know they are there, lurking within dense star clusters, or wandering the dust lanes of the galaxy, where they prey on stars or swallow planets whole. Our Milky Way may harbor millions of these black holes, the ultra-dense remnants of dead stars. But now, in the universe far beyond our galaxy, there's evidence of something even more ominous. A breed of black holes that have reached incomprehensible size and destructive power. It's taken a new era in astronomy to find them. High-tech instruments in space, tuned to sense high-energy forms of light, X-rays and gamma rays, that are invisible to our eyes. New precision telescopes, equipped with technologies that allow them to cancel out the blurring effects of the atmosphere and see to the far reaches of the universe. Peering into distant galaxies, astronomers are now finding evidence that space and time can be shattered by eruptions so vast they boggle the mind. We are just beginning to understand the impact these outbursts have had on the universe around us. That understanding recently took a leap forward. A team operating at the Subaru Observatory atop Hawaii's Mauna Kea volcano looked out into one of the deepest reaches of the universe and captured a beam of light that had taken nearly 13 billion years to reach us. It was a messenger from a time not long after the universe was born. They focused on an object known as a quasar, short for quasi-stellar radio source. It offered a stunning surprise. A tiny region in its center is so bright that astronomers believe its light is coming from a single object, at least 1 billion times the mass of our Sun. Inside this brilliant beacon, space suddenly turns dark, as it's literally swallowed by a giant black hole. As strange as they may seem, even huge black holes like these are thought to be products of the familiar universe of stars and gravity. They get their start in rare types of large stars, at least 10 times the mass of our Sun. These giants burn hot and fast, and they die young. The star is a cosmic pressure cooker. In its core, the crush of gravity produces such intense heat that atoms are stripped and rearranged. Lighter elements, like hydrogen and helium, fuse together to form heavier ones, like calcium, oxygen, silicon, and finally, iron. When enough iron accumulates in the core of the star, it begins to collapse under its own weight. That can send a shock wave racing outward. Literally blowing the star apart. A supernova. At the moment the star dies, if enough matter falls into its core, it collapses to a point, forming a black hole. Intense gravitational forces surround that point with a dark sphere, the event horizon, beyond which nothing, not even light, can escape. That's how an average-sized black hole forms. What about a monster the size of the Subaru Quasar? Recent discoveries about the rapid rise of these giant black holes have led theorists to rethink their view of cosmic history. Back in 1995, the Hubble Space Telescope was enlisted to begin filling in the details of that history. Astronomers selected tiny regions in the sky between the stars, looking north, south, and south again. For days at a time, they focused Hubble's gaze on these tiny patches of sky to examine the deepest regions of the universe. These deep field images offer incredibly clear views of the cosmos in its infancy. What drew astronomers' attention were the tiniest galaxies, covering only a few pixels on Hubble's detector. Most of them do not have the grand spiral or elliptical shapes of the large galaxies we see closer to us today. Instead, they are irregular, scrappy collections of stars. The Hubble Deep Field confirmed the idea that the universe must have evolved in a series of building blocks, with small galaxies gradually merging and assembling into larger ones. You can see evidence of this pattern simply by looking out into the sky. Many galaxies are gyrating around one another. Some are crashing together. Others ripping each other apart. Gravity calls the tune as these galaxies draw together, exchange stars and gas, and, over time, merge to form larger composite galaxies. Lately, though, this picture of a universe taking shape from the ground up has gotten a lot more complicated. The quick appearance of giant black holes and galaxies in the early universe is at odds with the gradual way matter builds up in most galaxies. They likely had their beginnings in the first generations of stars that literally burst onto the cosmic scene, in a time of incredible turbulence. These stars were born in knots that developed in the diffuse gas of the early universe. Gravity drew these knots together. In the most dense regions, the stars were born in waves. Many of them gave birth to black holes. Within a relatively short time by cosmic standards, the earliest black holes swallowed more and more matter, growing to monumental proportions, becoming quasars. These quasars, in turn, were fed by the collapse of matter on a much larger scale. This computer simulation recreates a region in the early universe that measured over 100 million light-years on a side. It shows what took place in the first 1 billion years of cosmic history. This virtual universe is set in motion by equations describing the properties of gas, the energy released in starbirth, and the outward motion of space and time. The result, an intricate cosmic web, with gravity drawing matter into filaments and knots, as if you were looking down through a vast tangle of interconnected spiderwebs. Inside the most dense regions is where the largest galaxies and black holes grew. Here, circles indicate the appearance of black holes deep in the data. As they bulk up by eating up their surroundings, the circles grow larger. A few, in the largest galaxies, reach ultra-massive proportions, billions of times the mass of our Sun. This is the scene in one of those dense intersections. Thousands of galaxies, and gigantic clouds of gas spiral inward. A large galaxy emerges in the center, and at its center, a giant black hole, force-fed by gravity. The orbiting Chandra X-ray Observatory was dispatched to look into distant galaxies for black holes on a growth spurt. Those that swallow gas and stars glow hotly in X-ray light, and Chandra found them. It even spotted some in pairs, black hole companions entwined in a dance of death. When the music ends, the pair swallows each other. That moment must be fast approaching for the largest black hole detected in the universe to date. It's a quasar called OJ-287. Flare-ups in the surrounding region suggest to astrophysicists that another black hole is flying around it. This giant's gravitational hold on its companion has led astronomers to estimate its mass at a whopping 18 billion solar masses. A monster this large and ferocious vents its rage on the surrounding universe and radically changes it. Just look at MSO 735. 2.5 billion light-years away. It appears in visible light to be a typical galaxy cluster. But in X-ray light, it's enveloped in a cloud of hot gas. Hollowed out of this cloud are two immense cavities, up to 600,000 light-years across. Now, add in a radio image of the cluster, and you can see two concentrated streams of matter pushing out from the center. That's a giveaway that the cavities were formed by an eruption in the core of the giant central galaxy. Two jets shooting out of the galaxy have launched blast waves that plowed through the gas between the galaxies. How much energy must that take? That of several billion supernovas, according to one calculation. That makes this the largest single eruption recorded since the Big Bang. Its source: a black hole that may weigh around 10 billion solar masses. But how does a black hole, a creature famous for hiding in the dark, emit this much energy? Well, think of a black hole as the eye of a cosmic hurricane, kept rotating by all the stars, gas, and other black holes that happen to fall into it. As this matter flows in, it forms a spinning donut-like feature called an accretion disk, which works like a dynamo. The spinning motion of that disk generates magnetic fields that twist round and channel some of the inflowing matter outwards into a pair of high-energy beams, or jets. How much energy depends upon the black hole's gravity, and how much matter has already crashed through its event horizon. Is this just another frightening spectacle of nature? Or is it part of a more profound process at work? Black hole jets have been seen all around the universe, including in our own cosmic neighborhood. This is Centaurus A, also known as the Hamburger Galaxy. In X-rays, you can see a jet erupting from the center, peering through the dense dust lanes that dominate our line of sight. Astronomers have come to believe that it's actually two galaxies in the act of colliding. Then there's the famous M87 galaxy, at the center of the Virgo cluster of galaxies, around 50 million light-years away. Astronomers have been intensely studying the 4 billion solar mass black hole that lurks in its heart. They found that in the tiny central region, the gas is whipped by gravity to orbital speeds of millions of kilometers per hour. That's powering a pair of high-powered jets that are plowing into the larger galaxy cluster. The largest black holes in the universe probably arose in the age of quasars, between 10 and 12 billion years ago. By releasing energy in the form of jets, they heated up the surrounding region. This prevented gas from collapsing into the center from the surrounding region and allowed smaller galaxies on the periphery to form and grow. But the monster's impact did not stop there. This Chandra image of the Hydra A galaxy cluster shows the same immense hot cavities glowing in X-ray light and a jet blasting out of its central galaxy. Gas along the edge of the jet contains high levels of iron and other metals, probably from supernova explosions in the center. By pushing these metals into regions beyond, a black hole seeds the universe with the elements needed to form stars, planets, and solar systems like ours. Those smaller galaxies then begin to seed their own environments. This computer simulation shows the fate of gas in the merger of two galaxies with black holes embedded in their cores. As the two pass each other by, the pull of gravity disrupts their spiral shapes, forcing huge volumes of gas into their cores. As these black holes continue to feed, they emit a series of powerful shock waves that push much of the loose gas beyond their boundaries. In the final steps of this ballet, the two black holes merge, emitting one final blast. Our Earth, our star, the Sun, our solar system, and ourselves. We all seem to be the beneficiaries of these faraway monsters. But equally amazing is the role these largest black holes play in the great cosmic struggle between gravity and energy.